All right, thank you very much. So let's talk about sustainable design practices in geotransportation. So first, let's define what a geotransportation is. It's actually the utilization of two different geodisciplines: geotechnical engineering that focuses on the soil properties, and the geological engineering that focuses on the rock properties, which then provides innovative solutions to solve the transportation infrastructures. The typical transportation infrastructures that we focus on are bridge abutments, earth retaining structures, roadway structures, as well as foundations. So why do we study geotransportation? Well, the design and construction consume vast amount of resources and energy. And that doesn't stop there, because the structures that are constructed over time, that needs to be repaired and ultimately needs to be reconstructed. So based on that, what are the sustainabilities that we can focus on in terms of geotransportation? Well, we could reduce the use of natural resources to construct these materials, minimize the use of energy, invent new longer-lasting materials, as well as reuse and recycle the existing materials. So how does GMU contribute to all of this? Well, my research team focuses on identifying the alternative materials to minimize the use of natural resources, and then evaluating these material properties, and ultimately creating design guidelines for implementation. So what alternative materials that we have been looking at to this point? We've been looking at demolished concrete, essentially as to create recycled aggregates, to construct new roadways, as well as earth retaining structures. Then we're also looking at old road surfaces that we're also creating recycled aggregates off of those, to construct dust-free unpaved roads that provides an alternative way to minimize the energy that's spent to keep the dust away, as well as road base layers. And then we're also looking at different synthetic materials to create reinforcement that will expedite the construction speed on bridge abutments. Material properties is one of the most important focuses of our study, because material properties impact the overall performance. And unfortunately or fortunately, the properties vary significantly from sources to sources. And so all of the recycled materials that we looked at also have to be evaluated for their environmental suitability, because we don't want to try to do something good and put a contaminant material into the ground. And then all materials then ultimately must satisfy the design requirements for short and long-term performance. These are regulated by the government agencies. In terms of design guidelines, what we have done so far is we looked at the use of recycled concrete for roadway structures and earth retaining structures and bridge abutments. These design guidelines are being prepared. And then quality control measures in the field to use reclaimed asphalt. And these are results of 4 different ongoing research studies that are going on. And then benefits of our research to our community is that we save significant air spaces. Instead of landfilling these materials, we're recycling them. Opportunities related to cost savings are significant, and also a lot of energy savings, because we're expediting some of these constructions with these alternative materials. So with that, thank you very much.